Hello.
Yes, sir. Very good evening, sir. Very good evening, sir.
You are able to hear me? Okay.
Yes, yes.
I am displaying my presentation. Okay. ये जो लाल लाल है इसमें क्या कुछ नहीं करना है बस इससे ना Yes, Amish, should we start?
Yes, sir. Our chairperson is just joining within 2 minutes.
Okay.
So
Now,
we
who is
start.
chairperson same or
Yes, yes, sir. Yes, sir. Our chairperson, Dr. Pooja Bhardwaj, ma'am, just joining within 2 minutes. Then we start the session, sir. Yes, yes, ma'am.
वाला जो पहले की दवाई थी वो लो पहले की। खराब है तो वो लेके देखो है तो कोई मंगा लो तुम्हें कितना बची रहना पड़ता मेरी दवाई तो आप अपनी दवाई खाओ हर एक की अलग दवाई है चलो
A warm welcome and very good evening to all dear participants. Resource person of today's session, Dr. Padam Singh sir, and chairperson of today's session, Dr. Pooja Bharadwaj ma'am. Today we are having another session delivered by Dr. Padam Singh sir. Yesterday we listened on the sample size estimation lecture 1, and today there is one more lecture delivered by sir. Yesterday we introduced sir, and it's our privilege to introduce again sir with some participants joined recently. Some are not presented in last session. Sir is held many important positions in Government of India. Sir has been a member of National Statistical Commission in Government of India during 2006 to 9 and served as a additional Director General of ICMR during 1997 to 2004 and Director at National Institute of Medical Statistics during 1987 to 97. Sir has worked as a joint advisor Planning Commission during 1979-27 and Professor of Statistics at Pusha Institute 1975 to 79. Sir has also been awarded the Sankiki Bhushan Award and is a fellow of the Society of Medical Statistics, which is highest honor for a statistician. Dr. Padam Singh sir recently awarded Pandit Ramakrishna Pandey Lifetime Achievement Award from the Institute of Applied Statistics in 2022. Sir awarded with Dr. P.V. Sukhatme Lifetime Achievement Award with 5 lakh cash prize from Ministry of Statistics and Program Implementation Government of India. Now I would like to invite sir to kindly lead today's session. Please sir, welcome sir.
Okay, thank you, Amit.
Welcome sir,
Your
welcome.
chairperson has joined.
Sir, he's trying to currently join. There is some network issue. He's just trying to still join. So we.
Okay, that's fine. That's fine.
Okay.
Okay. So, good evening, everybody. Please recall, yesterday we discussed determination of sample size, and I started with saying that statistics is meant for evidence-based decision making. And in this evidence-based decision making, there are two aspects which we deal with. One is estimation of parameters, that is prevalence, incidence of a disease or a condition, the effectiveness or efficacy of a treatment. This is one part, which is estimation. The other part is testing of hypothesis, where we try to test the significance of the difference between two groups, or we try to find out what are the determinants of disease, that is exposure, risk factor, vis-a-vis the outcome. Yesterday, we covered the determination of sample size for experimental studies, and there we discussed sample size determination for superiority trials, for equivalence trials, and as well as non-inferiority trials. Now, I think there were some questions on chat box. The sample size for, say, in vitro studies, as well as, phase 1, phase 2, phase 3, phase 4, how are these related? I thought, let me spend some time. Now, in phase 1, which is meant for assessing the safety or tolerability, and this is done with healthy human volunteers. And in phase 1 trials, sample size is small. This is generally taken as less than 20. In phase 2 trials, this is for determining the dosage and efficacy of a new drug in treatment of a disease or a condition. Target population here is patients of that disease, and the sample size, ranges between 100 to 200. What we discussed yesterday was that sample size calculation, under clinical trials. That is where we study both efficacy and safety of the new treatment. And we have comparative arms, the study arm, the control arms, okay? And here the determination of the sample size is on the basis of the formula which I explained yesterday in details, that if it is superiority trial, then how it is done, it is equivalence, how it is done, and when it is non-inferiority, how it is done. Phase 4, it is post-marketing surveillance. This is to monitor adverse reactions and other events attributed to the regimen. And this is mainly observational mode. Okay. Now, the phase 4 size, sample size is very large because we are looking at the adverse events. Now, in the animal studies and in vitro trials, there also sample size is generally small, less than 20. Now, while discussing experimental studies, yesterday I should have discussed the calculation of sample size for before-after study. Before-after study is also one of the experimental studies. And here, the parameter of interest is change in the variable under study, change. I am just taking an example. Supposing there has been an intervention, okay, on patients, and the parameter of interest is reduction in the tumor volume, okay, at 6 months from baseline. Okay. Now, the formula for estimation of change, if you see, it is Z alpha plus Z beta whole square. Then it is sigma square of difference. Now, it is not sigma of baseline or the end line. Here it is the variance of the difference in the, the value before and after. And delta is the change, so average change. So here in this formula, in terms of standard notations, Z alpha is the value of the standard normal variate corresponding to alpha level of significance. This is what we discussed yesterday also. Z beta is the value of the standard normal variate corresponding to desired power. And these values I said is 1.96 and 0.84 corresponding to 95% and 80%. Delta is the average of the change before and after, and sigma is the standard deviation of change. Now, with these values, one can compute the sample size. Now, let us take this example, the assumptions. The average at baseline, the volume of tumor at baseline was 3.5 units. After 3 months, it's okay. After 6 months, it changed to 2.7. So the change in the tumor volume is 0.8. Now we had sigma at the baseline, standard deviation. We had sigma at the end line, and we calculated sigma for the difference. It is 2.2. Z alpha value is 1.96. Z beta value is 0.84. The calculation, making use of that formula, you do substitute these values, and the sample size works out as 27. Now, this is a follow-up study. Change, 6 months. So, we assume loss to follow-up. And the loss to follow-up, if it is assumed as 10%, this 27 sample size is increased to 30. So, adjusting for loss to follow-up, the minimum sample size in this situation suggested is 30. So, for that intervention, okay, this is only before, after. There is no comparable group. Please note, it is one sample situation, before, after. So we have patients, there is a treatment or intervention on those patients, and we are trying to find whether the change is significant or not, or for that change, what is the minimum sample size required. This concludes the part that relates to sample size for experimental studies. Now let us come to observational studies. Now, what are observational studies? In observational studies, the investigator or the researcher observes the individuals for naturally occurring outcomes without manipulation or intervention. Please note, the investigator researcher observes the individuals without any intervention. And in observational studies, similar to that in the experimental, the parameters of interest are the proportion or average. And the objective of all these observational studies is estimation of these parameters. Please see my first slide where I said statistics deals with estimation and testing. Testing we discussed so far. Now we are going into estimation part. Here it is the estimation of parameters. Now let me start with estimation of proportions. Now I said the parameters are proportional or average. Now in calculating sample size, we need three things. One is, what is the anticipated or likely value of the parameter to be estimated, the desired confidence level, and precision or margin of error. Please see, the requirements here is different from what were the requirements in the experimental studies. Here we want to estimate that parameter precisely, so precision is required, and we have to attach a confidence level. So that's why we need three things. What is the likely value of parameter? What is the precision we want with which the parameter to be estimated? And lastly, with what confidence level? Now, let us take this example. Now, the parameter under study could be efficacy of a drug, effectiveness. Okay, the likely value here will be around 90%. So when we are dealing with the effectiveness or efficacy of a drug, the likely value of the parameter will be around 90%. The margin of error, precision is, inverse of margin of error. Less is the margin of error, higher will be the precision. So in the formula, we put the margin of error. Here, I have put it 5%, but it could be 10% as well. And the confidence level we have to define, say 95%. So if I have these three values, I can, make use of these and calculate the sample size. Let me take another example. Supposing we are interested in knowing what is the prevalence of vitamin D deficiency among hospital staff. Now, I am with Vedanta Hospital these days, and we wanted to do a study to find out, because they are working in the hospital, there is no exposure to sun, and we wanted to know what is the prevalence of vitamin D deficiency among hospital staff. And the assumption here was 20%. The margin of error is same, plus minus 5%, and the confidence level generally we keep at 95%. Many times the studies could be on adverse reactions. Now, adverse reactions are, not of that high value magnitude. It could be just 5%. And if 5% is the likely value of parameter, the margin of error has to be 1% only. It has to be much smaller than the likely value of parameter. The confidence level one can retain as 95%. And lastly, another parameter whose value is very, very small. That is microbial contamination. These are the types of studies we do in a hospital setting. And here, the value of the parameter will be 0.008. And here, the margin of error we keep at 0.001 with confidence level remaining as 95%. So please, the example I am giving is the likely value of parameter could be as large as 90%, and it could be as small as 0.8%. Okay, so we have to deal with all these situations and determine the sample size for each of these. Now, let us see how the sample size is computed. The formula is Z alpha square PQ by D square. Z alpha is the value of the standard normal deviate corresponding to desired confidence level. And when we talk of 95% confidence level, this value is 1.96. So approximately this formula reduces to 4 PQ by D square. So conventionally, in simple terms, the formula is 4 PQ by D square. You substitute the value of P, you substitute the value of Q. Q is complement of P, and D. And let me take an example. Now, these are the values of Z alpha corresponding to different confidence levels. We generally deal with 95%, where the value is 1.96. Otherwise, you can raise it to 99%, where the value will be 2.576, and likewise. Now, see this example. For evaluating the efficacy of a drug, that first row, where the likely value is 90%, what should be the minimum sample size for estimation of this with 95% confidence level and 5% margin of error plus minus. In this example, the likely or anticipated value of the parameter is 0.90, that is P. Q is 1 minus P, that is 0.10. Margin of error is 5 percentage points on either side, 0.05. The desired confidence level is 95%, so Z alpha value is 1.96. Substituting these in the formula, the sample size works out as 138. So we will need a minimum sample size of 138 to evaluate the efficacy of the drug with 95% confidence and within 5% margin of error. This is how the sample size has to be interpreted in terms of confidence level and margin of error. I hope this is clear. Let me take another example. Now, okay, before taking up another example, one might ask, supposing I change the margin of error from 5% to 2% and keep confidence level as the same in this example, how the sample size will change? Please see in this table, the figures, shaded yellow, is change in the assumption and the implication of sample size. The sample size here becomes 864. The third row, I have changed the confidence level from 95 to 99. And here, the sample size becomes 239. And in the last row, I have changed both the margin of error from 5 to 2% and the confidence level raised from 95 to 99%. The sample size changes. So please see, the determination of the sample size is, sensitive to these assumptions. Example 2. The example of the vitamin D deficiency, which I gave you. So what would be the minimum sample size for estimation of vitamin D deficiency among healthcare workers? Likely value is 20%. with 95% confidence and 5% margin of error. In this example, the likely value of P is 0.20. The Q complement of this is 1 minus P is 0.80. Margin of error D is 0.05. Desired confidence level is 95%, 1.96. I substitute these values here. And what I get is the sample size is 245. So we will need a sample size of 245 for estimation of vitamin D deficiency, among healthcare workers, where likely value is around 20%. Now, this is the same implication of change in the assumptions on the sample size. As the margin of error decreases, sample size increases. As the confidence level increases, the sample size also increases. This is the simple, explanation with the change of assumptions. Now, before coming to this, how I fix my margin of error? You see these two examples which I considered. The margin of error was same 5 percentage points. In the first example, that 5% was relating to p-value of 90%. So the ratio of D by P is 1 by 18. Okay. Whereas in the second example, the margin of error was same 5%, but the likely value of P was 20%, it is 1/4. So the relative margin of error is different, 1 by 18 and 1 by 4. So there is a suggestion, it is desirable that we keep this margin of error expressing in terms of relative margin of error. Okay? Say 25% of P, or 10% of P, or 20% of P. This is what it is. And if we do that, if we express the margin of error D as E into P, E is the relative margin of error with respect to P, then the formula reduces to N is equal to Z alpha square Q by PE square. This is, so the relative margin of error. Here it is calculation of sample size with relative margin of error. Now, these are the implications, but let me straight away come to this table. Now, with the same 10% margin of relative margin of error, if my p-value is 50%, the sample size required is 400. If p-value is 5%, then the sample size requirement is 7,600. If p-value is further low, okay, 0.5%, then the sample size requirement is 80,000. And if it goes further down, it is in lakhs. So what comes out here is that as the parameter under study becomes rare and rare, the requirement of sample size is more. Now this is the message, you have to take. If you are dealing with the rare situations, then the sample size requirement will be much more. And this is, in simple terms, if I tell you, for seeing a small thing, needle को देखने के लिए we need magnifying glass. Whereas something which is obvious, naked eye will do. Now this is the, the way one has to understand that for determination of the sample size in observational studies, it is the likely value of the parameter, it is the margin of error which you attach to this, and confidence level which together determine the sample size. Now, rare is the disease, higher is the sample size. This is what message one has to take. So this was when we were dealing with proportions. Let us come to averages. Yesterday also I explained that the difference between average and proportion is that PQ is replaced by sigma square. So it is Z alpha square, sigma square by D square. Here sigma is the variance or sigma is the standard deviation and other things are the same. Let us explain. This is what is required. We need the value of standard deviation. We need the value of confidence level and the margin of error. Say this example. What is the sample size required for a study relating to estimation of average hemoglobin level among pregnant women with the assumption of standard deviation as 15 and the desired of margin of error plus minus 2 with 95% confidence level. This is the simplest example one can think of. So sigma value is given as 15. D value is given as plus minus 2. Substitute these values here and the sample size works out as 216. So you will need a sample of 216 pregnant women to estimate the average hemoglobin level. Please see, while dealing with averages, we are not assuming the likely value of parameter. Here the assumption is only on variability. Whereas dealing with proportions, we were to assume the likely value of that parameter. One might ask, how do I know what will be the likely value of the parameter? No, it comes from the review of literature, your own experience dealing with this situation. Likewise, otherwise what we say, if nothing is known, then we calculate the sample size, which comes out maximum when p is equal to 0.5. The margin of error, if p is around 90, 80, we keep as 10%. If it is below 40, we keep it 5%. And if it is, in decimals, less than 1%, then we go in terms of relative margin of error. This is another example. A researcher wants to estimate healthcare expenditure for families living in a particular region. He requires to estimate, the within margin of error of 50 rupees. Okay? And the standard deviation, there is the assumption that standard deviation is 250. So if this is the information given to us, so the assumed standard deviation is 250, margin of error is plus minus 50 rupees, Z alpha value is 1.96. You substitute these values here, Z alpha square sigma square by D square, the sample size comes 96. So 96, families are required to be covered to estimate the out-of-pocket expenditure on health and with 95% confidence and within margin of error of 50 rupees here and there. Now, many times we do a study, as I explained yesterday also, without determining the sample size scientifically. We don't, determine sample size while undertaking a study, and we do it on the basis of, availability of subjects, on feasibility considerations and all that. If one has done a study with a given sample size, then, you may be required to find out what is the precision of my study with the defined confidence level. So this is the comment, and there is a formula that knowing the sample size with which we have undertaken a study with desired confidence level, I can find out what will be the precision of my study. So this is what it is. Now, under the head observation studies, we also have, sensitivity and specificity. Now, the sensitivity and specificity, these are measured in terms of proportions only. And when we are dealing with a diagnostic test, I would like to draw the attention of all participants. What do we understand by sensitivity and specificity in simple terms? The way I explained type 1 and type 2 error. Let us see this 2 into 2 contingency table. When we are dealing with a diagnostic test, there is something known as gold standard. Through that gold standard, we know the true positive and negatives. Using a diagnostic test, we know diagnosed positive and diagnosed negative. Let me repeat again. In this 2 into 2 contingency table, the columns are true positive and true negative. The rows are diagnosed positive and diagnosed negative. True versus diagnosed. Please see, it is subjects with disease, okay? Positives. Subjects without disease. This is, as per gold standard, true number. Whereas here, this side, it is test result. Test result means diagnosed positive and diagnosed negative. Now, the cell numbers which we have written here is TP. Please see what is TP. TP will be true positives diagnosed as positive. Okay? TP. In this cell, they are true positive as well as diagnosed positive. FP. FP is diagnosed positive, but they are true negative. So this is what we call as false positive. The next row, if you see, it is diagnosed as negative, but they were positive. So this is what we call as false negative. And the last cell is diagnosed negative, but they were true negative. So these 4 cell frequencies, they help us in determining sensitivity and specificity. In simple terms, let me explain what is the meaning of sensitivity. A test will be called sensitive if it captures all true positives. Okay? No positive should be missed. That is the definition of a sensitive test. A sensitive test has to capture all true positives. Whereas specificity is that the test will be called specific if it captures all true negatives. Okay? So this definition of sensitivity and specificity one has to understand. If you see from the column, the total positives, true positives were TP plus FN, out of which TP were diagnosed as positive. So the ratio of this TP divided by TP plus FN, this is what we call as sensitivity. Okay? Let me repeat again. Out of the total positives, how many were diagnosed as positive by the test? That ratio is sensitivity. Similarly, out of total negatives, the number diagnosed as negative, that proportion is what we call as specificity. And this is what the notations given: true positives, false positive, true negative, and false negative. Next slide, I have explained the term. What is sensitivity? So sensitivity is defined as the ability of a test to identify correctly true positives, okay, out of those who had the disease. That is, out of those who had the disease, how many it could identify correctly as diseased. Therefore, sensitivity is the ratio of subjects tested as positive to total positives, total diseased persons. So the sensitivity, as I said, is the ratio of TP divided by TP plus FN. This is also known as true positive rate. This is another term used for sensitivity. And now if false negatives rate or miss rate is the complement of true positive rate. Okay. Now the formula here is A. Supposing those frequencies are A, B, C, D, capital A, B, C, D, then it could be A by A plus C. Any questions on this definition of sensitivity? अमित कुछ है चैट बॉक्स में? नहीं है.
No, sir. No,
Okay.
sir.
Now similarly, I am defining specificity. Specificity is defined as the ability of test to identify correctly the true negatives out of those who do not have disease. Therefore, specificity is the ratio of subjects tested as negative out of total negatives. So this is Tn divided by Tn plus Fp. And sensitivity and specificity of a test do not change with the prevalence of the disease. Okay? This is the specificity. This is also known as true negative rate. You know, if ABCD, that, you know, in terms of Tn and Fp, it is defined that way, but in terms of ABCD, it is D divided by B plus D. Now, here we were considering the columns. Now, supposing out of the total row, the number examined as positive, out of that, how many were true positive? That has also to be defined. Please see this. Positive predictive value, PPV. It comes from the row. So the positive predictive value of a diagnostic test is the probability of test, okay, that is out of the total positives diagnosed, what proportions were true positive. Please see the difference between positive predictive value and sensitivity. Sensitivity calculation is from the column. That is the same cell A as percentage of the column total is sensitivity. The same cell A as the percentage of the row total will be positive predictive value. So this one has to understand. The numerator remains the same. It is same. True positive is the numerator. If true positive is divided by all total positives, is sensitivity. If true positive is divided by all diagnosed positives, it is positive predictive value. I think this difference one has to understand. That's why I am hammering. Similarly, the negative predictive value. The negative predictive value of a diagnostic test is defined as the probability of a test to detect the true negative cases. That is, out of the total negatives diagnosed, what percentage were true negatives. This is what is negative predictive value. So there also, the D, if you take as a ratio of that total, column total, it is specificity. But this D, if you take as a ratio of the corresponding row total, it becomes negative predictive value. So these two terms, you know, many times there is a confusion. So this is what I am hearing. One has to be very clear in this. Now, then one can also talk of overall accuracy. The diagnostic accuracy of a test is expressed as the proportion of those individuals who were correctly diagnosed as percentage of the total. So it is true positive plus true negative divided the overall sample size. That is what we call as overall accuracy. Now let us come to determination of the sample size. For a test with known or desired sensitivity or specificity. Let us take one example. Now, calculation of sample size. There we had, one situation where the objective of the study was to assess the diagnostic efficacy of Doppler ultrasound in evaluation of vascular, complications of the orthotopic liver transplant cases in comparison to, this is what we call as sonioelastography, which is the gold standard. So there is a gold standard. As against that, we want to see if the cheaper one, which is the Doppler ultrasound, to what extent, we can use that if we know the sensitivity, specificity, and all that. Please see, this is estimation of sample size for proportions. The notation here is SN is for sensitivity, SP is for specificity. This SN will be in proportions. So the formula, if you see, it is Z alpha square PQ by D square divided by the prevalence of that condition, positives. What proportions are positive? Let me repeat again. The formula here is the same formula which we use for estimation of sample size for proportions. There the formula was Z alpha square PQ by D square. Please see here, the Z alpha square, instead of P, we are taking SN, sensitivity. 1 minus SN is complement of that. Below that is D square. But we are dividing by the proportion of the true positives, prevalence. If we are dealing with the disease condition, then it will be prevalence. Similarly, for specificity, the formula is same Z alpha square SP, that proportion which is a measure of specificity, 1 minus SP, D square also comes here, and then we have 1 minus prevalence, that was for positives. This is for proportion of negatives. So it will be 1 complement of that. Now, the notations are here, and let me take up one example. In this very example, suppose my sensitivity was 92%, specificity is 97%, the prevalence of vascular complications in that situation is 14%. The level of significance I assume is 5%. Okay, that is 95% confidence level. Margin of error is 10%. Now these values, if I substitute in the formula which are there in the earlier this thing, substitute the value of Z alpha as 1.96, the sensitivity as 92%, specific, and then 1 minus sensitivity is 8, so 0.92 into 0.08, D is 0.10, and the prevalence is 0.14. And if you substitute all these values here, the sample size works out as 202. This is for sensitivity. Now the same way, if I calculate for specificity, the proportion is 97. So Z alpha square 0.97 into 0.03 divided by D is same 0.10, and 1 minus this prevalence will be complement of 14%, that is 80.86. If you substitute these values here, the sample size works out just 13 for specificity. Now, I have to estimate both in that given situation. And if I have to estimate both of these, then the maximum of this sample size, which comes on the basis of formula for sensitivity, and specificity, that has to be taken as the recommended sample size. The recommended sample size here is 202. Let me take one more example. Now this is, in this, the objective of the study was diagnostic accuracy of, this is some GDCEMRC in identifying the suspected, tumor locations against the intraoperative findings. Through operation, when you do, one will know where was the location. Now there is a diagnosis which claims that it can, locate the tumor location. Now, in that situation, the formula remains the same. The assumptions are, that is given in the next slide, that is sensitivity is 91%, specificity is 95%, the prevalence of that condition among the suspected cases is 75%. The level of significance, confidence level, it remains the same, 95%, margin of error 10%. And here, if you substitute the values, the sample size corresponding to sensitivity is 42, and that corresponding to specificity is 73. As I said, of these two, I have to suggest the one which is maximum of the two, and the sample size there works out as, suggested is maximum of 42 and 73, which is 73. Now this is what I thought I should be covering when we deal with estimation of sample size. It is just one condition which I explained, is simple estimation of parameter, which is proportional to the average. And another, the sensitivity, specificity is generally discussed separately, but because these are also in terms of proportions, so I thought of covering it here. So this is, I think, my presentation. And if there are questions, Madam Chairperson, Amit?
Yes, thank you very much, sir, for your interactive session, a very knowledgeable session. I hope that participants get benefited from the overall session yesterday and today. If there is any query, then please raise your hand or write your query in the chat box.
Or you can send me otherwise.
Yes, sir. Yes, sir. Definitely. We are just providing some time.
Yes.
Our chairperson, ma'am, is still trying to connect. There is some network issue, and still
No
trying to connect. We just wait for 2 minutes for the ma'am. He's still trying to connect with us. And then I request to all participants if there is any
I think
query
joined,
in the chat box.
I hope it was not very heavy.
Yes, definitely.
I tried to explain in simple terms these terms, otherwise, the sensitivity, specificity, even understanding, explanation. Okay?
Yes, sir.
So
Yes,
that,
sir.
one can relate it with the type 1 and type 2 error. Okay? That way also.
Yes.
So the sensitivity and specificity, one can relate with the type 1 and type 2 error, which I discussed yesterday.
Yes, sir. Dr. Sarai Kure, you have wrote in the chat box that I have missed some part of presentation. If I have any query, then I can send it. It was nice. Thank you, ma'am. Definitely. For that, we are already providing the recorded session through the app, and you can access for a year anytime the lecture delivered today. We are providing all lectures in a recorded format for a year. So anytime you have any doubt, again listen that session. And we also share the PPTs in that case, if you have missed any part of the session.
So I think good comments I am seeing.
Yes, sir. Yes, sir.
Box.
Yes, sir.
Okay. Thank you, participants, for appreciating the lecture. So I had 4 lectures, 2 on sampling and 2 on sample size. Okay.
Yes, sir. We are also receiving feedback on the mail also. We are
Acha.
receiving lots of feedback from yesterday. Very positive feedback, sir.
Please share those queries to me.
Yes, sir,
Let me
definitely.
also see. Okay.
Definitely. Definitely. Our respected chairman, ma'am, Dr. Pooja Bharadwaj, ma'am, is still trying to connect, but ma'am, I think not audible. I'm just trying to connect you, but I think there is a network issue at your end. Okay. So I think ma'am is not. Ma'am, just share me your views on the session through the mail, and I will forward it or communicate it with the participants in the next session. I think there is a network issue at your end, so you're not able to connect with us. I'm not able to get your voice. I see your name, but I'm unable to listen you, ma'am. So thank you very much, sir, for making session very interactive, very knowledgeable with discussing all queries of the participants. Uh, this is the end of today's session. Now, on the basis of Institute of Applied Statistics and NIA Jaipur, we heartily thanks to all the participants and this is person of today's session, our respected Dr. Padam Singh sir, and our chairperson Dr. Pooja Bharadwaj ma'am for joining today's session. I thank to all participants for their commitment during the session and
Thanks
making
everybody.
session very interactive. Thank you again, sir, for your presence and very nice lecture, sir. Thank you again, sir.
Yes, हो गया बेटे.
This is the end of today's session. We have another session tomorrow on effective conclusion writing delivered by Dr. Puneet Ori, sir. Thank you. This is the end of today's session. Thank you. Thank you very much.